How are you, my student? My name is Purity Anzelimo. I'd like to welcome you to our lesson today. Our topic for today is differentiation. That is our topic today. And in the previous lessons, we said differentiation is simply the process of finding the gradient function, the process of finding the gradient function or the derivative, And we said very well that when we have an equation y is equal to x raised to power n, then the derivative dy all over dx will simply be equal to n x n minus 1. And again we said when you find the derivative dy dx of a constant is simply equal to 0. So I would like us to look at the differentiation of y is equal to x n kx raised to power n. In our case here, you can see here the coefficient of x is 1, and in the equations that we had the coefficient as 1. So I want us now to consider a case whereby our coefficient is not 1, but it is a certain constant more than 1. So we are going therefore to have, when we want to find the dy all over the dx, it will simply be we differentiate x raised to power n, but then we multiply by the constant. So the constant, we just multiply by that constant. So the constant is there, we multiply by the derivative of this, which is n x n minus 1. So it's simply finding the gradient function of x raised to power n, then we multiply by the constant k. So that's how we find the derivative of the equation y is equal to kx raised to power n, such that if we are finding the gradient function of y is equal to 2x squared, it simply means that dy all over the dx will therefore be equal to, we have our 2 which is our constant, so we need to differentiate this, which is now 2x 2 minus 1. So we are going to have this as 2 into bracket, we have 2x raised to power 1, and therefore we have 4x, because x raised to power 1 is the same as x. So we have our derivative as 4x. So that is the derivative or the gradient function of the equation y is equal to 2x squared. Again, if we have another one here whereby y is equal to negative a half, then we have x raised to power 4. Again, we follow the same. Our constant here is negative 2, and therefore our dy all over dx will be, we have our constant which is negative a half, and then we find the derivative of x raised to power 4, which is 4x raised to power 4 minus 1, which is going to be negative a half. We multiply by 4x raised to power 4 minus 1, that is 3. So we end up getting by 2 and by 2, we get negative 2x raised to power 3. So that becomes our derivative for the equation y is equal to negative a half x raised to power 4. Again, this is our A, our example B. Again, if we have the following, y is equal to 3x raised to power negative a half. Again, we follow the same to find the derivative. So we are going to have dy all over dx to be equal to 3 is the constant. Then we find the derivative of x raised to power negative a half, which will be negative a half x raised to power negative a half minus 1. So we are going to have 3 negative a half x. We have negative a half minus 1. That will be negative 1.5, which is the same as negative 3/2. And therefore, we are going to have, when we multiply this by this, we get negative 3/2x raised to power negative 3/2. And that will be now the derivative of the equation y is equal to 3x raised to power negative a half. So that's how we differentiate. And differentiation, we have differentiation of that. So that's how we differentiate the equation y is equal to kx raised to power n. So we have to multiply. We just find the gradient function of x raised to power the n, and then we multiply by the constant. Like in our case here, the constant is 3. Here the constant is 2, so we are multiplying by this. So we are not differentiating this constant. So we still have the 2. We have the negative a half, then we differentiate the x raised to power 4. So I would like you to do the following for this before we move on to the derivative of a polynomial. I would like you to differentiate the following. Differentiate the following. In the first one, we have y is equal to 2x raised to power 3. Then we have Roman 2, y is equal to negative 1/4 x raised to power 5. Then we have number 3, y is equal to 4x raised to power negative a third. And finally, number 4, y is equal to negative 1/5 x raised to power 10. We can have raised to power 11. So I'd like you to differentiate this, or to find the derivative, or to find the gradient function. I would like us to move on to another part, still on differentiation. That is the process of finding the gradient function, or the process of getting the derivative. And I want us to look at the derivative of a polynomial. Derivative of a polynomial. How we can get the derivative, or how do we differentiate a polynomial? Now, if we have this kind of an equation in the form, if we have this kind of an equation whereby we have a maybe 0, then we have x raised to power n, we have maybe a 1, x raised to power n minus 1, plus we have a 2x raised to power n minus 2, up to an, and then x raised to power whichever the n minus a certain number up to the last term. We say if we have this kind of an equation, therefore we say this is what we refer to as a polynomial. For example, if we have, and in this case our a0, our a1, our a2, all these are constants. These are constants. And therefore, if we have the equation of this form, maybe our a0, we have 4x raised to power 5. Then we have maybe 3, or maybe can even have more, 5. Then we have x raised to power 4. Then we have plus maybe x raised to power 3. Then maybe we have even minus. We have minus 2x raised to power 2, and so on. If we have such an equation, this one is referred to as a polynomial. This equation whereby y is equal to that is referred to as a polynomial. And therefore, we want to know how do we find the derivative of a polynomial. So in this, for example, if we take this example where y is equal to x raised to power 5 plus 5x raised to power 4 plus x raised to power 3 minus 2x raised to power 2, when we want to find the derivative or the gradient function of this polynomial, we simply differentiate separately. We differentiate these terms separately. Like in this case, we have this term, we have this, we have that, and we have that. These are the terms. These are the terms. So for us to differentiate or to find the derivative of a polynomial, we need to differentiate separately. We differentiate each term separately. Differentiate each term separately. And that is the process that we are going to follow. We want to find the derivative of this polynomial, so we need to differentiate each term separately. If you have a polynomial of this case, and we are always asked, for example, to find the degree of this polynomial, you look at the value, the power, that is the highest power. If you want to get the degree of the polynomial, just before we differentiate, degree of polynomial, we get the highest power. The highest power, in our case here, because we have the polynomial of x, so we are going to get the highest power of x. In our case, we have x. We get the highest power of x. In all that we are doing is a polynomial in x. This is a polynomial in x, a polynomial in x. In our case, we are using x. We can have a polynomial in another letter s, a polynomial in v. So when we want to differentiate, we differentiate each term separately. Then you also need to know that the degree of a polynomial is simply the highest power of x, such that in our case here, in the example that we have here, we can say that the degree of this polynomial, we look at the highest power of x, which is 5. And therefore, we can say in that one, the degree is 5. The degree of that polynomial is 5. If we have another example whereby we have, for example, 3x squared maybe plus 2x, the highest degree is 2. And therefore, we can say that the degree of this polynomial is 2. So I want us now to be able to find the derivative of that polynomial. We can start with the one that we have here, whereby we have, so we look at examples whereby we are find the derivatives of the following equations. Find the derivatives of the following equations. So we have Roman 1, we have y, which is equal to 4x raised to power 5 plus 5x raised to power 4 plus x raised to power 3 minus 2x squared. So that's what we have. We can even add it to continue. Maybe we can even have plus 3x, then plus 7. So here we can add 3x plus 7. The powers of x are decreasing to 1 up to 0. So we are told to find the derivative of this equation. And we have said to find the derivative, we differentiate each term separately. So we are going to differentiate each term separately. So dy all over dx will therefore be equal to, we differentiate the first one, which will be now 5x raised to power 5 minus 1, which is 4. Then plus, we have 4, so we have to multiply all that by 4. We have only differentiated, we need to multiply by the constant. So we have 5x raised to power 5 minus 1, which is 4. Then plus, our coefficient here is 5, the constant. So we have here 4x raised to power 3, then plus, here we have 1, so we are going to have 3x, 3 minus 1, which is 2, then minus, we have 2, then we have, this is, we are going to have, we differentiate x squared, which is 2x raised to power 2 minus 1, which is 1, then we have plus, we have our 3, into bracket, when we differentiate x is raised to power 1, so we are going to have 1 multiplied by x, then 1 minus 1, that will be equal to, we are going to have therefore 3, then we have our 1, because this is raised to power 1, then we have x raised to power 1 minus 1. That's what we have, and 1 minus 1 is equal to 0, so we can put this one 0. Then plus, when we differentiate a constant, we say that we get a 0. So we are going therefore to have our dy all over dx as, now we can open the brackets, we get 20x raised to power 4 plus 20x raised to power 3 plus 3x squared minus 4x plus a number raised to power 0 is 1, so plus 3. So this is the dy all over dx of this equation. So we have differentiated each term separately to get that derivative. Again, we can differentiate the second one when we find the derivative for the second one, whereby we have y is equal to 3x squared plus 2x. So we want to find the derivative, which is dy and dx. So we differentiate them separately, this separately, and the other one separately. So this constant, we are just going to multiply by, when differentiate this, we have 2x raised to power 2 minus 1, that is 1. Then plus 2, then we have, this is raised to power 1, so we are going to have 1x raised to power 1 minus 1, which will be equal to 0. So we are going to have this 3 times 2 is 6x, then plus, this is 0, a number raised to power 0 is 1, so plus 2. And therefore, our dy all over dx will be equal to 6x plus 2. That is the derivative. Again, I would like us to find the following. Also find the, we must not have the polynomial in x. We can have in another letter. For example, we are told in the following, find the derived function. Find the derived function. Well, this is simply the gradient function of each of the following. Of each of the following. Find the derived function of each of the following. In the first one, we have s is equal to 2t cubed minus 3t squared plus 4t. So in this case, our polynomial is in t. So we are going to have, therefore, our ds all over dt. That is our gradient function, ds all over the dt, will therefore be equal to, we differentiate each separately. So in the first one here, we are going to have this one as 2, we multiply by 3t squared, then minus, we have 3 into bracket, we have 2t, then we have 2 minus 1, which is 1, then plus 40, we have 4 into bracket t raised to power 0. So we end up getting these as 6t squared minus 6t plus 4. And that is the derived function of this equation. That's the derived function. Again, we can do another one whereby we do not have the x. Instead, we have another function whereby we can take another example whereby we have been given that our a, that is B. A, we have it as v squared minus 2v plus 10. So that is what we have, and we want to get the dA all over the dv. We want to find the derived function, so we are going to differentiate each separately. So this one will be 2v, 2 minus 1, which is 1. Then we differentiate this whereby we get minus 2 into bracket, we have v, 1 minus 1, that is 0. Then the derivative of a constant is 0. So we end up getting 2v minus v raised to power 0 is 1, so minus 2. And that will be the derivative or the derived function of this equation. Again, we can move on to more examples. Write down the gradient function of the following curves. Write down the derivatives of the following. Write down the derivatives of the following curves. We are going to do again 2 questions, then we do other 2. In the first one, we have been given A. We have been given that y is equal to 2 pi x, and we want to find the gradient function or the derivative of this. So in this one, we simply need to come and know that this one simply means y is equal to the square root of x. From the law of indices, again, you learn that when you have a number, the square root of a is the same as a raised to power half. And therefore, this one simply means it is 2x raised to power half. So we want to find the derivative of y is equal to 2x raised to power half. So we find the dy all over dx. So dy all over the dx, therefore, will be equal to, our constant is 2, then we multiply by a half x raised to power a half minus 1. So we are going to have this as 2 into bracket a half x, a half minus 1, we have negative a half, and therefore we end up getting a half times 2, which is 1. So we end up getting x raised to power negative a half. So that is the derivative of y is equal to 2 square root of x. Then another question, part B. So in that case, we can have it this way, or simply, this one simply means it is equal to 1 over the square root of x. It is simply the same, because when we have it this way, this negative will mean that we are dividing by the square root of that x. So it is still the same. If you write it at that or at that, it's the same. So then question number B, we can have y is equal to x cubed plus 4 all over x squared. We find the derivative of this equation, x cubed plus 4 all over x squared. Again, it is very easy because you just need to write it. Y is equal to, this is a common denominator, so it means that it is x cubed all over x squared plus 4 all over x squared. That's what it means. So you can cancel this by x squared, 1 by x squared, you remain with x alone. So this one simply means you have x power 1, then plus 4 over x squared is the same as 4x raised to power negative 2. From the law of indices again, this is our y. And therefore, dy all over dx, that is the derivative, will be, this is raised to power 1. So we are going to have 1 times x. 1 times 1, we have now 1x raised to power 1 minus 1. Then plus 4 into bracket, we have here negative 2x negative 2 minus 1. So we are going to have this one, this is 0, this is 0, then we have therefore number raised to power 0, 1, so we have 1 plus, this is negative 8x raised to power negative 3, which we can simply write as our dy all over dx, therefore will be equal to 1 plus and minus, we have minus 8x raised to power negative 3. So that is the derivative for the equation y is equal to x cubed plus 4 all over x squared. So those are the derivatives. Then we can move on and again do another example. Again, you can write this one just as we have done here. You can continue with this one and say this one is the same as 1 minus 8 all over x cubed. It still means the same, so you can write it in that form or in this form. Then I want us to do some more examples. In this case, we are given the following. We ask the following question. So you can be asked any question from this, provided you know how to differentiate, you can be able to answer any question. Like in this question here, we have been told that find the gradient of the curve, y is equal to x squared minus 4x plus 6 at the point corresponding to the value of x at x is equal to 3. That's a very good question. We have been told to find the gradient of the curve y is equal to x squared minus 4x plus 6 at the point corresponding to the value of x at x is equal to 3. So we are finding first the gradient of the curve, and when we are finding the gradient of the curve, it is simply finding the derivative. And therefore, we start by finding the gradient, which is our derivative, dy all over dx. And we have our equation. Our equation is equal to, we have our equation. We can start with writing the equation y is equal to x squared minus 4x plus 6. And therefore, when we want to find the derivative dy all over dx, we have, therefore, we are differentiating them separately. So here we have 2x raised to power 1 minus 4 into bracket x raised to power 0, then plus the derivative of a constant, which is 0. So we are going to have 2x minus 4. That's what we have as the derivative. So our gradient, which is the derivative, is equal to 2x minus 4. That is the equation. But then we are told now to find the gradient to the curve, at the point corresponding to the value x of x at x is equal to 3. So here it is at a certain point where x is equal to 3. And therefore, our gradient will therefore be equal to, this is the equation for the gradient, but we have at point x, which is 3. So where we have x, we substitute with 3. So we are going to have 2 multiplied by 3 minus 4. So we are going to have 6 minus 4, which is equal to 2. So our gradient at the point corresponding to x is equal to 3 is equal to 2. So when you are given the equation of the curve, you need to get the gradient function, dy over dx, you get the gradient function. Then at that point, you need to get, if it is at point x, which is equal to 3, you substitute x with 3, and you get the gradient, which in our case is equal to 2. Then we can do another example, maybe the last example. In this, finding the derivative. So we have Another question, in this we have been told, find the coordinates. Find the coordinates. Find the coordinates of the point. Find the coordinates, just the coordinate of the point on the curve, and the curve is y is equal to 6x minus x squared, at which the gradient is equal to 0. The gradient is equal to 0. So this equation, find the coordinate of the point on this curve at which the gradient is equal to 0. So when we are told to find the coordinate, we need to get the x and the y value. The x value and the y value forms the coordinate. And we have been given that the gradient at that point is equal to 0. So we need to get that point where the gradient is equal to 0. And since we have the curve y is equal to 6x minus x squared, we need first to get the gradient function dy all over dx, which will therefore be, in our case, be equal to 6, then minus 2x. That is the gradient function. And we are told that at that point the gradient is equal to 0. And therefore we just come and equate this function. 6 minus 2x is equal to 0. The gradient is 0. So we want to get the value of x when the gradient is 0. So we are going to have negative 2x is equal to 0. We can take 6 to the other side. We have minus 6. So negative 2x is equal to negative 6. Can divide by negative 2 by negative 2, and therefore our x will be equal to 3. So that is the value of x is 3. So we also need to find the value of y. So from this equation we have y is equal to 6x minus x squared. So we need to get the coordinate, and we have the value of x. So we need to find the value of y. So we are going to have 6. Our x is 3. Minus our x is 3 squared. So we have 6 times 3, that is 18, minus 3 squared, which is 9, and we have 9. So the value of y is 9. And therefore the coordinate where the gradient is equal to 0 for the curve y is equal to 6x minus x squared is therefore equal to our x is 3 and our y is 9. And that's how we write the coordinate. We separate the two values by a comma, and then we enclose them in the brackets. So we have 3, 9 as the coordinate where the gradient is equal to 0. So therefore, anytime you are told to find the derivative, the gradient function, you simply need to differentiate. So you simply need to differentiate. And simply when we are differentiating, we are finding the value of dy dx if we have y, which is a function of x. You can have y, which is a function of another value, or maybe v, which is a function of s, which is a function of t, and so on. So to find the dy dx, it is simply the differentiation, whereby we have n x n minus 1. And that's how we find the derivative. Again, when you are told that it is at, you have been told to find the actual gradient of a curve at a point, you need just to get the gradient function, and then after getting the gradient function at that point, at x equal to 3, you need to substitute the values of x with the value you've gotten for x and get the actual gradient at that point. So I'd like you to do the following exercise. I want you to differentiate the following. Differentiate the following with respect to x. with respect to x. Differentiate the following with respect to x. In all the questions that we have done in this question and this one, we are differentiating with respect to x. So in the first one, A, we have x in x squared into bracket x plus 3. So you differentiate with respect to x. Then in the second one, B, you have x squared plus 4 into bracket x plus 1. So in this one, you need first to expand this before you differentiate. You need to open the brackets here. Then finally, part C, we have 4x cubed minus 3x and all of it over x cubed. So that's number 1. Then question number 2. Question number 2. Question number 2, you are told to find, number 2, find the coordinate. Find the coordinate of the point. Find the coordinate of the points on the curve. It's one point on the curve y is equal to 6x minus x squared, at which the gradient is equal to 2. At which the gradient is equal to 2. Then again, you need to find the following. Then number 3, find the derived function. Find the derived function. Find the derived function, that is dy all over dx, if in the first one, Roman 1, y, if y is equal to 3x squared minus 7x plus 10, then Roman 2, y is equal to negative 1 over 10. Roman 3, we have y is equal to x raised to power 4 minus 4x raised to power 3 plus a half x squared. And finally, question number 4. Question number 4, we have the following question. For number 4, we are still in the gradient function. So for question number 4, find the gradient. Find the gradient of the curve. Find the gradient of the curve y is equal to 2x squared minus 4x plus 2 at the points corresponding to the values of x at, for the first one, whereby x is equal to negative 2, and number B, when x is equal to 0. So you find the gradient of that curve. So ensure that you do this. By so doing, if you do all these and you are able to get them right, then you are able to differentiate a polynomial. So ensure that you follow that. Anytime you hear find the gradient, it simply refers to finding the derivative or the gradient function. Then when you hear finding the gradient of a curve at a certain point, then you require to get the gradient function. Then from the gradient function, you are going to get the value of the gradient at a certain point, for example, when x is equal to 0 or when x is equal to -2. Thank you for being attentive. Let us meet during the next lesson.